guys can see the screen okay? Okay. Miu, you can see the screen okay? Okay, so the topic that we'll be talking about today is Java interfaces. I think this is going to be the first time that we introduce you guys to the concept of interfaces. But before we talk about the interface, I want to just briefly mention the rules for attendance in this class. I talked to Ajahn Ativong, and we feel like we could check for attendance by passing around a sheet of paper for you guys to sign at the 9:15 time mark, and then check it again at the end of the class. So this is just a way to encourage you guys to be here on time and stay throughout the lecture. I will try my best to keep the class entertaining. So there will be no random checkup or anything. We'll always check attendance at 9:15 and again at the end of the class. Okay, so now you guys know. Oh, I forgot to ask you guys, how was the homework, by the way? You guys were able to do okay? How was the homework? Get homework? Okay. I don't know if Tato, the name, Tato, I don't know if she was able to finish. She asked like question last night really late. All right, so let's dive into interfaces. Essentially, so in the last lecture 2 weeks ago, right? If you guys remember, we saw a picture of a cell phone, right? And we were talking about how, as a cell phone user, you don't really have to care the implementation, like how the phone was made, right? The processor, just close the door, it's a bit loud. Right, so last week we were talking about the phone, right, as an example. You can have a phone, and with that phone, as a user of that phone, you don't really care about the implementation, like what type of processor it was made out of, maybe how much memory it has, or what the storage is. Well, you do care about the storage, right, to store your files, but you don't care like what's the brand name of that memory storage. And you only care about how to use it, the functionality, right? And that is along the same line as interface. Interface essentially describes to you, right, what the class does. If you look at on the diagram that we have up there, you can look at interface as a service provider that can do multiple things. So it provides what we call a contractual interface, a promise as to what the class can do. So in this example, we have do action 1, 2, 3, 4, right? A bunch of actions that this class can do. So there are two things. First, the interface lists what the class can do, right? And secondly, it hides the implementation. By that I mean, when you look at an interface, you only see what the class can do, but not the implementation. And that's really important because when you develop a large application, a lot of times you can't develop everything by yourself, right? Sometimes a lot of times you'll have to reuse classes or software packages from other vendors or your friends. And you don't have all the time in the world to try to understand every single implementation, like how all the classes were constructed. So a lot of times you would simply just look at the interface of the class, or in other words, like what the class can do. So here is just to reiterate the point that I mentioned in the previous slide, that an interface, right, can exist on its own without having to include the implementation, right? So all this is probably quite abstract right now, but we'll show you an example of how to use the keyword interface in Java. By the way, how many of you have used the keyword interface before in your code or in your project? No? Okay, Puti. So to understand the slide, I think that we can think of the cell phone as the primary example of how we can understand the slide. So can you list me probably, so instead of looking at behavior 1, 2, 3, let's look at a behavioral cell phone. If we are talking about an interface of a cell phone, oh wait, can't really draw on the whiteboard, have to draw it here. Oh wait, but then we wouldn't be able to see that slide. So I'll just use the whiteboard, but I'll write bigger. All right, so cell phone, right? This is almost like a recap of last week's lecture. So can someone help me name one of the behaviors that a cell phone should be able to do? Call. Make a call, right? So one thing is you can call. Okay, what's the other thing?
Message.
Okay, you can send like SMS. All right. Okay, I want one more.
Car bomb.
Car bomb? What do you mean? Huh?
MMS.
MMS? Okay, well, that's kind of like SMS. I mean, what else can you use your cell phone for? You use it all the time.
Game.
Okay, game, application. Okay. I'll just go a bit more generic, yeah? Application. I was looking for like internet connection, but all right, application is fine because that actually is what we use it for, right? So typically, I mean, these days, if we're going to buy a cell phone, right, we definitely expect it to be able to make a call. SMS, do we care so much about SMS anymore? Not really. I mean, I still use it occasionally, but not primarily anymore. Application, definitely, right? I mean, if you got a phone that you can't like run an application on it, if you can't install apps, then like what's the point of having the phone? So these are the three behaviors, right, that we expect from a cell phone. It doesn't matter if it's an Android cell phone or iPhone or Nokia. BlackBerry 10 is coming out. Anyone has been following the demise of BlackBerry? Does anyone know when it's coming out, BlackBerry? The version 10 that supposedly revived the company? Guess not. I think the share is selling at $8 a share right now. It used to trade at $40. Yeah. So what are the phones that we have in the market today? We have what? iThingo? iPhone. So we have iPhone, we have all the Android phones, and what else? We have the Windows phone, right? So you would expect that so this is the application of that, like a more concrete example, right? You have the interface of a phone, right, up top. You expect it to be able to like do these three behaviors, and the classes that derive from the interface. So you have like the cell phone interface as a class, right? And then you would have subclasses like the Android, iPhone, and then like the Windows Phone. So you would expect that all these classes have those behaviors, and the interface, the Java keyword interface, is a way to enforce those behaviors on those classes. So I know that these phones are hardware phones, right? But let's suppose that they were software classes, right? So if I were to give the Windows Phone class to, what's your name? Nat. So if I were to give the class Windows to Nat, right? Your job is to implement the three behaviors to make this class able to execute the call method, the SMS method, and the application method. It's supposed to be able to do those things. Same thing here. If I gave the iPhone class, right, to Tato, is that how to pronounce your name? Okay. If I were to give it to Tato, you would also have to be able to also be able to implement those three methods, right? So is that clear? Like why we need an interface? Just to recap, right? First is to list out the behaviors that you want, like a group of classes to be able to perform, right? Secondly, it hides the implementation, so you only have to care about the interface. And lastly, it's a way to enforce that all the classes that derive from the interface class do have those behaviors that you want. So the keyword that we use to derive, quote unquote, derive from the interface class is the keyword implement. Okay, so we say that any classes implementing interface X on the top there must implement, and the keyword is implement, right? Implement all the methods. In this case, would be behavior 1, 2, and 3, declared in interface X. Those classes, by those classes, I mean the derived classes may have additional methods. You are not restricted to just 3 methods, right? So someone give me an example of what an iPhone can do, but an Android phone cannot do? FaceTime. Can an Android do FaceTime? They probably call it something else. I'm just kidding. Okay, let's do it. FaceTime. Okay, FaceTime. All right, we have FaceTime. So these are the methods of the iPhone class. What about Android? What are some of the things that Android can do that an iPhone cannot do? What? Huh? Oh, NFC? S-Beam, yeah. Well, that's not really Android, is it? Yeah, okay, yeah. Hey, so
I got one just to promote Android. It's a best kept secret that line stickers, official line stickers can be downloaded and use Android without having to add up to your account.
Oh, take that, iPhone users. On Android, for the Line application, you can actually download the stickers without even having to have an account, right? Or something like that.
To add the sponsor, you can download.
Yeah. time to convert. So just to apply it to the example that we have up there on the slide, we know that all of these phones can make calls, can send an SMS and receive SMS, and we can use applications on them, right? But the point that I'm trying to convey here is that these derived classes do not only provide those three methods. They can, by themselves, provide other methods that might differ from other classes. So I hope that's clear that based on this example, like an Android can use NFC or have line stickers, whereas iPhone do not have those methods, but have like FaceTime feature, for example. So is that clear so far? So when you see these, right, I mean, they're just classes, right? Java classes with these methods. Yeah. So now let's talk about the UML notation for interfaces, and we expect that you would know this as well. Really quickly, do you guys remember if the lines are not dotted, what does that represent? If we had just something like this. We talked about it quite quickly last week. Yeah, hierarchy, or in like OO, we call that inheritance, right? So the difference between inheritance and interface is just the interface. We use a dotted line to represent an interface. Okay, so I hope you guys see that the concept of interface and inheritance are closely related, and you shall see really soon when we dive into the code that they are used almost the same way, but different keyword. So the key takeaway from this slide is simply just knowing that the dotted lines, whenever you see a dotted line, you can infer that X refers to an interface. All right. So we were talking about just interface as a concept, not really tied to Java. But now we are talking about Java interfaces. Okay? And in Java, a class may implement more than one interface, right? I'm not sure what, we'll give an example of like what kind of class you can have like multiple interface. But an interface also provides a mechanism for callbacks, like pointers to function in C++. An interface can extend another interface. All these are just sort of additional caveats that we just want to mention. But let's take a look at an example of what an interface looks like. Okay. So if we talk about a workstation, right? A workstation is just a computer that is used in an office setting, okay? What if one of the things that you want to be able to do to that workstation is to be able to name it, right? Well, yeah, let's go with that example for now. This is an example of how you would use an interface, for example. Okay, up top, right? You would create an interface called nameable, okay, as an example, and you see that it has two methods, okay, set name and get name. So, whichever class that implements the interface nameable has to be able to set its name and also be able to retrieve the name. So how do we implement this in a concrete class? So let's say that we have a workstation class, right, that we want to be able to name it. Then you would just use the keyword implements down there, implements nameable interface. And then you are, as a class developer, you are responsible for implementing these two methods. Okay? And it's pretty simple, right? I mean, you pass the name to it, and then you just set the machine name or the private member that you use to store the machine name. Same thing with getName, just return the machine name. The point here is just to show you the syntax, how you would use the keyword interface and implements. Okay. Some of you might ask, like, what's the big deal? Like, why do we have to have this? Why do we need to use something complicated where we can just use something like class workstation? So I'm just going to call work S, and then have set name and get name method. Why do we need to use an interface here where you can just create a workstation class with two methods? You're done, right? You're right that we can also implement it like that, but what if we also had a personal computer class? So I'll just abbreviate it as PC. And I want it to be nameable as well. Like, I want to be able to name my class. So, like I mentioned in the previous slide, right? A way to enforce that the classes share the same characteristic, the same behavior, is to use the keyword interface, right? So, you don't want to, the problem that we can run into, let me just erase this and like draw it neatly. Let me just recap or go back a bit. So I have two things. I have a workstation class and a PC class. I want both of these nameable. If you got people in the back who can't see, just let me know, okay? I'm going to have to keep reminding myself to write bigger. I want both of these classes to be nameable. If we did not have the concept of interface, okay, we might run into the problem of where, like, one developer might call the method on with the workstation, set name, whereas the other person might say set. Hold on. Can someone look up on Google for me if this is the Spanish word for name, nombre? Okay, let's say like the two developers were from two different countries. One is from England and the other one is from Mexico. Right? He might just want to call, okay, then this is actually not a good example, right? Because like set is an English word, but you just go along with me. So the point is that if you did not have an interface to enforce the method names, then two developers coming in, they might name two different things. Now, you might ask, like, well, is that like a bad thing? That's not necessarily a bad thing. It depends on the situation. But the bad thing here, I think, is that if a third person came in, right? A third person came in to look at the two classes here, they might think that these two methods do two different things. Whereas, I mean, they really do the same thing, right? Just setting the name of the class. So this is why an interface is useful. In this case, it would be the proper usage of interface, or why you should have an interface, is if you have multiple classes. Like if you had more than just a workstation, if you had a PC as well, a personal computer, okay? So now that, so this is the first example. The second example, real quickly, so you have workstation and PC, and both of them derive from or implements the nameable interface, right? And now both of these classes are required to implement the set name, same method name, yeah. As a developer, when you develop a large application, there's a lot more complexity that needs to be solved than trying to figure out if the two methods do the same thing. Okay. All right. Well, in the next slide, you see how I have another example, right? So we're not talking about two closely related concepts anymore. We're not talking about workstation or PC. It could be even something else entirely, right? Like a student. A student has a name, no? Right? What's your name? What's your name? Phon. Oh, you're Phon. Phon has a name, right? Who doesn't have a name here in this class? Everyone has a name, right? Every single student must have a name. At the very least, you must have an ID. So in this example, then, we have student. So usually in inheritance, right, you would derive from a base class that shares pretty much the same concept. So let me elaborate what I mean by that. An animal, right? An animal, give me an example of an animal. Dog. What else? Cat. Is that an animal? I guess it is. No, just kidding. So, oh wait, forgot. So, inheritance. Usually you would derive from the base class that share the same concept. All right, this is a bad example. I'm going to remove because this will go on the video and this is like, what kind of animal is a party animal? Okay, shark. Okay, that's inheritance. Remember, this is a solid line. But over here, when you have interface, you have a workstation and a PC. They're closely related, right? They refer to a computer. But you have a student. That's a human. Okay, but what we are concerned here is not the, how should I say? We're just concerned about the behavior, the methods that each of these classes should possess. And in this particular example, we only care that all these classes must have the set name method. Is that clear? Yeah. So that's a subtle difference between interface and the inheritance. Okay. Fields in interfaces. Just a little note that if you have any fields, so I said that an interface must just simply have the methods, right, without the implementation. But you can actually add member variables, okay? But they're not really member variables, they're actually member constant, because if you read the slide, it says that if any fields are put into the interfaces, then they'll automatically be static and final. Do you guys remember the meaning of the keyword final? In C++, that or C, that'd be like const, You can't, it's a read-only data. You can't make changes to it. Static meaning that, static, let me see if I can explain this simply. So static means that there's only one instance of that member. When you instantiate a new class, it's not allocating a different piece of memory to hold that here's what I mean. Let me see if do you guys know the meaning of static already? If you do, then I don't need to explain it again. I'll just explain it anyway. Static is a way to save memory, at least from my point of view. Usually, okay, I can erase this now. Oh, sign. Do you know NICE? You know, when I was teaching Intro to ICE, in our last class, I let the students ask me any questions. So they submitted a bunch of questions, right? And NICE submitted me 3 questions. And one of the questions was, if you could choose to be an animal, what kind of animal would you be? So I told her, party animal. That's lame. Where were we? Oh, here. Static. Yeah, static, thank you. Not party. That's after class. It's Friday. Where are you guys going? Sala? Hey, you, the foreign students, you guys should try out the clubs here. I think they're pretty nice. I like them a lot better than the ones in the US. Because the ones in the US, as a guy, you actually get treated as a second-class citizen. And by that I mean, I don't know why is it like that in the US, but over there in the US, as a guy, you always have to pay to get in. Usually it's about 600 baht to get in. And the clubs, I think there's a shortage of women in the US for some reason. It seems to me that they try to keep the guys out to keep the ratio between men and women in the club the same. So, you know, if you're a girl, you just get in, right? You don't have to pay, you just get in. But here, but for guys, you have to wait. So it must mean that there are less women than men. Well, I'm just mentioning. So, but here in Thailand, you don't have to wait. You just get in. Yeah. Huh? Lady Moore, yeah. Oh, and also over there in the US, once you get in, then there are these like big, you know, Hulk bouncers that always look to throw you out of the club. It doesn't make for a pleasant experience because you feel like you're being constantly watched for anything that you do. Over here, you don't. They only watch you because they want to sell you drinks. You know, they just want to sell you more drinks. Okay, the keyword static. Why am I talking about these things? Like, it must be Friday. If you want to have a place to go check out, this is it. Okay, that's the last thing. Last thing. Oh, for guys, hot chicks are here. But it's hard to get a seat here. You have to like make advanced reservation. But I know a couple people that owns a Mellow, so might be able to sneak you in. Should we still talk about static? Let's talk about clubbing. All right. Okay, let's go back to the animal class with no reference intended to party animal. Hattori. This is inheritance. Solid line. We just need like a cat. Oh, by the way, I know that this might sound sort of naive or dumb or whatever, but you can have more than 3 subclasses, okay? And you don't have to always have 3 subclasses. I'm afraid that some students would see that I only draw 3 subclasses all the time, meaning that you can only have 3 derived classes. You can have as many as you want, or as many as just one. Okay. I have to make sure that I say this because, like yesterday, some of the students came to ask me questions, and I saw firsthand how students can take things too literally. So I have to make sure that I convey, hey, after class way. All right, let's talk about static. We have plenty of time, sort of. Let's say that the base class has cat, okay, bird, cat. Let's say that we're talking about home animal. Okay, bad example, but the number of legs. So if we know that we only have 2 derived classes, which are dogs and cats, how many legs do they have? 4. I know this is a bad example, but I'm always bad at coming up with things on the fly. So number of legs is 4, right? This is a private member variable. Okay. If you put static in front of it, when you instantiate these 2 classes, there's only one number of legs in terms of memory. But if you did not put static, then for each class that you instantiate, each class will have its own number of legs, 4. So is that clear? If you have static, all the classes share the same variable. But if you did not have static, each class gets its own number of legs. I mean, this is a really minor point, but I'm trying to just explain the difference or what is static used for? Why do we have to use it? Okay. Public class C implements X, public class. So here, the keywords static and final are optional. Okay. So you can see here, we have interface X that contains a member variable called D, a member constant actually. And then we have a concrete class called C that implements X, right? And you'll notice that in that class C, there's nothing in there, right? And yet, when you actually instantiate it here, right, new of C, the new C class there, you can actually get the D member variable, right? Even though the public class C has nothing. So this works sort of like inheritance, right? But I just wanted to show you that all the classes that implements the interface automatically get the member variables that belong to the interface that it implements. Okay.
If you were to put static final when you are implementing double, would it produce the same result?
Yes, because those are just optional, like, yeah, just optional. I was just joking that you guys should go clubbing tonight, because after I took a look at the homework, I don't think you'll be going anywhere. So who has taken a look at the homework number 2? Yeah? Yep. Hell starts now. Okay, at first I wanted to talk about homework number 2 at the end of the class after we've already introduced all the concepts that you guys need to know for homework 2. But I felt like I need to show you the homework, what is involved to do the homework, and tell you like all the concepts that you have to pay attention to the rest of the class. That way you know when you listen to the rest of the lecture today, you know what to pay attention to. Everything actually. So Ajahn Adiwong was kind enough to prepare. Hello. Oops. Hello. 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 He was kind enough to prepare a video of how your homework is supposed to look like. So let me play that video. Hey Putti, did you know that, man, I look like a handicapped person. Did you know that Quicksilver was Alfred was developed to compete against the Quicksilver? Alfred is free, you know.
Quicksilver is free too.
Well, I'm not arguing that, but the Alfred it was built to sort of like overtake the Quicksilver crowd.
Customizable Quicksilver.
Hey, it is customizable too. It has extension, but you have to pay. Geek moment. Okay. Hello. Hello. Hey, actually, one question that I have is how many students we have in this class? At first I thought there were only 40 of you remaining. But it seems to me, at least in our Facebook group, we have like 55 members. Okay, minus 2, Ajahn Adiwong and me, right? That means that there are 53 students. Oh, third year also signed up? Oh, I see, right, because it's not like intro to ICE where only like first year students take it. Okay, yeah. So we probably have like what, 52, 53 students.
Maybe after midterm.
Let me see. Well, at least this is just a video, so. So this is an example of that Ajahn Adiwong created for you guys so that you guys see an example of what your homework might look like. So who do you think this looks like? It is a clock, but remember, if you look at the homework, right, the face is supposed to be an avatar of someone. Blue hair devil. So what do you notice about this? First of all, let me ask you, like, what kind of Java application is this? An applet. Good start. All right, so it's an applet. Do you remember the applet that we were showing in the class last week? What was the difference between that one and this one? Perfect. What's your name again? Viriya. You don't have a nickname? We. Good. So two things, right? First, it's an applet. Second, it's an animation. It's moving. Yeah. And those are the two things that we'll be talking about the rest of the class today. One is how to make an applet, okay? And secondly, how to animate an applet using a concept we call thread. So who has done multi-threaded programming or has, babbled into the world of threading? Not yet? That's okay, because in the next week, you'll be using threads to animate your Hattori. Did you know that in your second year class, I think that I've discovered now who are the loudest. One is we have Hattori. She likes to go by the name Ja, and then the other one is Net. when they came to my office hour on Wednesday, I think everyone left. I mean, everybody else that was not in our class, they could not take the chatty mouth. Anyway, so let me just play it again. So we already identified, the first time around we already identified the concept, the Java concepts we'll be learning, right? And in the homework, I think you're supposed to implement it such that the eyeball follows or tracks the time, right? So that's your homework. First is to draw the avatar, and secondly is to animate it so that it looks like a clock. Good? I forgot to ask, like, if anyone has any questions about the homework. We will talk about the homework in detail, like the last 10-15 minutes of the class. But so far, does anyone have any questions in terms of like what the homework is supposed to be? No question. Good. So Sai, you probably have to cut out your activities for the next week. Cannot start like Wednesday and expect it to be done by Friday, you know, this time around. Okay, so two important concepts that we'll be covering in our class today. One is applet. I mentioned that. You need that to be able to draw the clock and the avatar. And secondly, you need to know about threads to be able to do the animation. So now you know what to pay attention to. We are going to start diving into applet. It's the first thing. And you know that the example that I'm going to give in class is going to be very, very easy and very dumb. So in other words, you guys have to, you know, do the hard work, figuring out how to draw the face. But I saw Ajahn Antiwong's code, and there were like about 1,000 lines of code. I think it's only a single text file, right? Ajahn, what? Hattori?
I have a question. I don't know the difference between interface and inherent. What is the difference?
Well, you came in late. That's why you don't know. It's okay. We can talk about it again. No, but like we were talking about how here, this is comparing inheritance and interface. Here. I think for interface, okay, well, I guess I have to ask you a question. Like, why do you care to know the difference between interface and inheritance? No, that's not a trick question, because like I want to know like why do you when I ask that?
Because I asked my friends to explain.
Oh.
And I explained interface, and then I discovered with last year I learned inheritance, so I think that is the same thing.
They're similar, but they're not the same. So we'll just briefly go over it again. So everyone should be looking at Jai and give her a hard stare for coming in late. Okay, we have two examples. Yeah, no, I'm just kidding, by the way. It's no problem. So we have here is the inheritance. This is interface. The first difference between the two is that for the easy one, we'll just get the easy one out of the way. The UML the UML notation is different. For interface, you have dotted lines right here. Can you see? And for inheritance, you have a solid line. So let me just describe these two diagrams first. So you have an animal as a base class. So this is inheritance, right? So you're familiar with the concept of a base class, right? So you have a base class of an animal, and then deriving from that base class, you have three concrete classes. And those are dog, cat, and shark. Used to be party, but I changed it to shark. Then over here, you have a nameable interface. And not deriving, okay? The keyword here is implementing. So that is another, that's the main distinction between inheritance and interface, is that whereas I use the verb deriving right here, huh? Or extends. Well, I mean, I don't mean like the keyword, but yes, you're right. Okay, extend. So extending from animal, you have dog, cat, shark, right? Over here, you have classes implementing the interface, okay? I think the main difference is that an interface is a technique, an OO technique, to enforce that the class implementing the interface have the methods that the interface lists. So we had an example of how it's gone now, but we had like a cell phone interface almost, and then we want the cell phone to be able to make calls, to be able to send SMS, and to be able to run apps. Like when you implement that as an interface, these classes must have those methods down here. So, in this example, we have set name and get name. And the interface up here, it just has a blank method. By that I mean it just set name and get name with no implementation. So the unique thing about interface is that it only specifies the interfaces, the methods that the classes implementing it should have, and the class implementing the interface will have the implementation down here. So if you look at set name, the implementation will be down here. Okay, so that is interface. For inheritance, you don't have that enforcement. If animal has eat method and walk method, the dog, cat, and shark will inherit or extend. Yeah, I think use the word inherit. Will inherit those methods as well. And these methods, unless they're pure methods, will have implementation right in here. And the dog, cat, shark do not have to implement those methods. That's one of the first differences, or the main differences. Yeah? Okay. So coming back to applet. So we're going to take a break at 10:30, 25 more minutes. Okay.
So you spend some time in the paint method, fill out the detail how to make the applet resemble your beauty, alright? And then after that, when you create a clock, do not spend the effort in that again. Think about how to reuse that, right? Basically in the instruction, it says that you will create my avatar clock by extending from my avatar. Alright? The reason for that is that you should not re-implement the details that you will sweat over when you try to draw your beautiful face. All right? You should somehow reuse that. One trick, well, I'll just tell you that we expect you to call super paint from your paint method of the subclass, right? And super paint will activate the details of the painting for you. And then in your subclass, in the class, you just draw something that are extra from what you already implement. What is left from super paint, you draw that in your subclass, right? But in the example, it's okay if you will create a bigger eye and somehow place the moving eyes on top of the original eyes. That's fine also. Well, whatever you would like to do, right?
I think that's all.
Yeah.
So that is all that we have prepared for today. And at 1 o'clock today, at the common room, I plan to hold an office hour for students who still have trouble understanding Git. And if you have any questions about today's lecture, I'll be there at the common room, 1 p.m. today. And the office hour probably lasts about an hour or two. So if you want to come, ask any questions about the homework, that's fine. Okay? So I guess I'll see you guys next week. Thank you. Why it became so popular was that back when the internet just got started, an applet was how people could animate the web page. These days, what we use to animate web pages, to have animation, we usually use Flash or HTML5. But back in the day, it was applet that ruled the world. Okay. So that was the selling point of why, or what got applet to be really popular, because you could actually embed it into HTML. 10 or 15 years ago, HTML or web pages were just web pages. They were just documents, like text documents that had pictures and occasionally it had sound, but they didn't have a standardized technology back then to animate the web page, like to have, like that clock, the homework 2. If you wanted to have something like that, there was no HTML syntax that supported that. So they used applet to make that happen. These days, applets, the only time I ever use applets is like when I visit a really university websites written by these really old professors. They don't use new technology, they just keep using applets. And there's nothing wrong with that, right? I think at the end of the day, we just care about functionality, even though it looks a bit old. So just a little caveat that a Java program can be designed to function as an application or as an applet, or both an application and an applet. So an applet, you've already seen what it looks like, right, last week. An application, here in this context, we mean it could be like a console application or a GUI application. A GUI application is anything that does not look like a console, a terminal. And so the important key, however, is that a Java applet is not a standalone application. So it does not need a main method. So please raise your hand if you don't. No, raise your hand if you know what a main method is. Nobody raises their hand. You guys, I just want to check. You guys know the main method, right? Yeah, okay, good. Well, in applet, you don't have to have a main method. Your main, quote-unquote, main method is the paint method, right? We already talked about this last week. An applet is invoked in an applet context. By applet context, we mean that it already has an application that that contains it. Okay. Like if you remember last week when we wrote that first program, Hello World, I did not have to write the code to draw the window. I just had to write that, okay, I want to have the text hello world. So I'm going to show the example real soon, but I just want to point out that to develop an applet application, you focus on what you want to draw on the screen and not about like the screen itself. Okay. So this is an example of an applet that is embedded within a web page, right, on the right-hand side. And as an application developer, you extend from the applet class, and then one of the methods that you have to override or implement is the paint method. And whatever that you put in there then will get drawn on the screen. So now some code. So if you wanted to write a hello world application or applet, just want to draw, if you want to just draw the text hello world on an applet, the first thing that you have to do is you type public class hello world applet, and then you extend it from this class called applet, which belongs to the, if you look at the import in red, it's java.applet. That's a really bad name. I mean java.applet.applet. Okay, so that's the first thing that you have to remember. So you don't have to write all these down because the slides have already been uploaded. You can always refer back. So try to pay attention to the points, different points that I'm trying to point out, rather than try to memorize. Yes, Ajahn.
I would like to add to Ajahn Siva's mentioning about the import applet. One question that I would like you to think about, you should be able to answer this one by recalling about the notation, recalling what we talked about the notation of how we name identifiers. So anyone can tell us what's the difference between the word applet in the middle, java.applet, and the last part, the applet that is the last part of the second line.
Yes. Up here. So we have import, the second line. We have import java.small case applet dot big case applet. His question is like, what's the difference? Like, why is one lowercase and the other one? Puthi said that the lowercase applet is a package, and the uppercase applet, or the capital A applet, that refers to a class. And we talked about this last lecture, so he got it right. Too bad there's no prize for you. I'll see you at Fala tonight though. Okay, so that's one. And then the second thing I want to point out is that your the main method, just like how you create a Java application, you have to have a main method. In applet, you implement the paint method. Okay, so let me ask you. So if I did not put anything inside the paint method when you run the applet, what's going to happen? Just a window, right? The important point that I want to convey here is that when you develop an applet, right, you are not building the application from scratch. Okay? You are actually extending or customizing how an applet looks. This is why I asked the question. If I did not put the g.drawString, right, I think you can probably infer from the slide here that when you have drawString and then you pass in the string, it will write some string on the screen. But if you did not have that, right, you still have a running application. although I mean it doesn't do anything, it's just a blank screen. But the important point that I want to you guys to take away from this is that when you write an application, this is an example of how you work with a framework, you work with a library, and you extend its behavior, to do something you want. In this case, we wanted to. Sorry. Hey, what happened? Okay. In this case, you want to draw a hello world string. Okay. You customize the framework to do what you want to do. So is that clear? The key takeaway from here is that the paint method is going to be where the bulk of your code, resides in. This is your main method. Okay, graphics G. The way I understand this graphics class is it's just a canvas. It is a place where you pretty much do anything. If you want to perform any actions on the applet, this is the class that you do it to. Hattori. By the end of the class, by the end of the semester, I think everyone will remember you as Hattori and not Ja, because I call on you so often. So a graphics object is passed to paint, so that's done automatically, okay? And this object can be thought as the canvas to be painted on. So if we go back to my original question, asking you guys, if I did not have the drawString method called on the G graphics object, what would happen? You would just get a blank screen. Let's demonstrate that. I'm sorry guys, I'm gonna use a different editor than the one that you guys use. I was trying it out last night and I found that I like this IDE the most for now. So I'm going to run. Okay, so I'm going to run this. So you guys can see, right? This is pretty much the same code as what we have on the screen. And if I run this, yeah, I run it correctly. Hey, oh, well, there's nothing on it. Let me run this. Oh, I ran the wrong application. Control-Shift F10. So this is the applet with the drawString method, right? So you can think of G representing the entire screen that you see here, right? And then the method that we invoked on it was the drawString, so it draws the hello world string on it. If I did not have this line, just to demonstrate, F10, then you would simply just have a blank canvas, a blank screen. So when you think of the graphics class, then think of it as that screen visually. That's what I'm trying to convey. Yeah. And so when you look at that graphics class, right, it's just a class. So it must have associated with it a bunch of methods, right? And one of the methods that you can perform on the graphics class is the drawstring method. Now, the question I want to ask you, which is going to be very important for your homework too, is how do you know that there's the drawstring method on the graphics class? Is it because you are, what's the word, psychic? You can read? I mean, you know that there's a drawstring method on it? How do you know? How do you know that a class has a drawstring method? Java doc. So the point that I'm trying to tell you guys is that to do homework 2, you're going to have to look up the methods that you can perform, for example, on the graphics class. Because I can assure you that you will need much more than just a drawstring method to do your homework 2. So Java docs will be your friend. Does anybody have any other good Java resources to look up, the methods associated with the frameworks API or classes besides Java docs? No? Yes? So for now, what? Google. Oh, yeah. Yeah, Google. Bing.com. Let's not go there. Hey, what's the one made by the Chinese? Baidu. Yeah, Baidu. Good luck reading that. It will all be in Chinese. So just to explain this method, the drawstring method obviously draws a string, but the 100 and 102 numbers that follow is the location on the canvas, the pixel location of where you want the text to be drawn. So how do you know that? You have to look it up online in Google, using Google or in Java docs, okay? Or you can ask your friend too. Yeah, I forgot to mention that is also another resource, your friend. This is just showing how to embed an applet inside a web page. The code down below here is the content of my webpage.html. You guys are familiar with a .html file, right? Essentially a text file. So first of all, it's a text file, not a binary file. Let me take a little detour. All of your first year students know this by now. But what is the difference between a binary file and a text file? When we say a binary file, what is a binary file? And when we say a text file, what is a text file?
Binary for machine to read.
Yes. Yes, that's a very good question. Were you in my class? No, just kidding. So one of the things that I covered in Intro to ICE, okay, was the difference between a binary file and a text file. And what's your name again? Good? Yeah, he's really good. So the difference between a binary file and a text file is that a binary file is a file that is created, that is meant for machines or computer programs to read, whereas a text file is created such that it's made for human to read, okay? So can someone tell me now if this is a text file or a binary file, an HTML file? It's a text file. Because if it was, how do you know that whether or not a file is a binary file? You know it when you try to open a binary file with a text editor, and then all you see is just like a bunch of, garbled, like whatever garbled number, characters, weird characters. If anyone plays computer games, Yeah, actually, you don't even have to use computer games like a .exe for those Windows user. If you try to open a .exe with a text editor, all you will see is just like a bunch of garbage, not text. That is an example of a binary file. Okay. A .bin on Unix, for those of you who use Mac and Linux, a .bin file is an example of a binary file as well. So here's a text file and here's an HTML file. We're going to cover So when I'm really angry at you, I'm going to start calling you by your real name. So an HTML file is a text file that has a markup language, okay, that is used to describe what the web page looks like. But for now, you guys don't have to know this because we'll cover web technology later in the course. But for now, just know that this is the syntax to embed an applet inside your HTML page. You don't have to do this for your homework, okay, because you are just going to be developing a standalone Java applet. You don't have to embed it into your HTML page. So the slide here is simply just trying to show you that what it looks like, right? Another example. I already showed you what the Hello World applet looks like using my computer. I just thought of something and I want to just show it to you guys real quickly. So you guys see here on the screen, do you notice that it looks different compared to your Eclipse? Okay, I know it's a different program. I mean, that's a given. I use IDEA, IDEA, IntelliJ IDEA. But what's unique about this text editor? It's black, right? Thank you, Wee. So whatever text editor you guys use, I strongly recommend that you set the background and the text to be dark like this, because it's easier for your eyes. And why? What's your thoughts? It's too hard to read. Oh, is it hard to read when it's on the screen like this? On the computer, it's fine. So it's easier for the eyes, yeah, because you don't have to look at something so bright, okay? After I've been programming or using computer extensively, I always prefer to look at dark screen like this. So you don't have to strain so much to look at the text. Okay, going back to Applet. Okay, so the next thing that we're going to do now is instead of just drawing a Hello World program or doing a Hello World program, we are going to draw that image, standstill image, okay? And the purpose of this is to not only show that you can do other things besides putting text on the screen, but also to introduce you to other APIs that the graphics object or the graphics class supports. So instead of using the slide, I'm just going to go to my IDE and run the application from there. So we have our first example here, and I'm going to run it. And for those of you who did not, who haven't checked the Facebook page, this is what you can do if you install the application called SizeUp. Whoops. You see how you can like move your window by using just key presses. Like I press Control Alt Option and then C, it will center the window. You can also do like this. I'll just demonstrate. And the reason why it's important, right, is because as a developer, a lot of times you have to have multiple windows shown on the screen at the same time. And instead of using your mouse to like resize the window, you know, and then place it at the right place, it's really a waste of time. So I use an application called Size Up. Sorry, there's no such, I mean, I was going to make fun of Windows user, but you actually have other applications that you can use for this too. But on the Mac OS, you can install Size Up and you get this capability for free. The ability to manage your windows, to resize your windows. Okay, that's all I wanted to mention. Just Google Size Up, you'll see it. And if you need a license key, just come talk to me. I have one. So I have okay. So how do we draw that image? So since this is a canvas, right? The first thing that you should probably want to know is that you have to draw it from the bottom layer up. So in this image, what is the bottom layer? What is the color of the bottom layer? Purple, right? In the Java framework, they use magenta for that color. So this is why the first method call that we use is to set color. So when you set color, think of it as you pick up a pen by that color. And then when you call fill rect is when you actually color the canvas. Okay. 1010 and 6060 is the coordinate of where you want to paint it and the size of the rectangle. Okay. And then to draw to paint blue, you just repeat the process, right? Now we want to paint it smaller, so that's why we make the box smaller, 40 by 40, and we just set the color to be blue. And to close it off, we want to draw a circle, which is yellow. So we set color to be yellow, and then instead of using a fill rect, which stands for rectangle, which is short for rectangle, you call fill oval to draw a circle. That's all. Now, this is one example. I also have another example. And I want you to help me figure out what the difference between the previous one and this one. So this one fills the entire screen, right? Let me just go back. Oh. We're almost done. So let me just finish covering applet. So this one, if I resize it, do you notice how the blue rectangle always stays in the middle? Yeah? If I resize it, yeah? Whereas in the other one, it's fixed size, right? So what am I trying to tell you here? Let me go back to the code here and run. Applet is really low level. if you want the screen to be resizable, like your applet to be resizable, like in this case, you have to code that up, right? You have to manage that yourself. So if you compare the code here, for example, if you look at the code here when we fill the magenta background color, you'll see that we don't fill fixed size anymore. In the previous slide, I think it was 60 by 60, but here we actually get the dimension of the window and fill it to that size. You see on the first line there, right under paint, we have dimension d equals to this.getSize. That method retrieves the applet window size. Now, my question is, we did not have a this variable inside this class. I mean, do you see a private member variable called this at all in this class that we're declaring, which is called drawing demo2? So my question is, where did the this variable come from? Do you guys see the this? A little hint. The this variable is highlighted in a different color. So there must be something unique about this variable. So who knows the answer? Good? Is it still good?
This instance.
It's this instance. Okay, and well, what are you trying to say?
Has the value. It has the method getSize, which has the value of the.
Good. I mean, good start. Definitely not bad. So what is the this variable? What is it? Maybe this is a good time to practice looking up on Google. I mean, why is the this? Okay, my question is, where did it come from, and what is it? Why is it called this? Do you guys remember? This class. Right. So one explanation that I can say is that the this variable is a special keyword in Java. When you're dealing with class, the this variable refers to the current class that you are working on. So in this example, the this variable refers to the drawing demo2 class. So what we're saying here is that the this variable has a method. I mean, this class must have a method called getSize. But then my question is, do you see the getSize method defined anywhere on in this text? Found? So where did it come from? From applet, right? Because we've been talking about how inheritance works, right? And one of the features of inheritance is that whatever base class that you extend from, so in this case applet, you automatically get all the public and protected methods that belong to that base class. So in this example, the getSize method comes from the applet base class. Now, let me be precise. It could come from the applet base class, or maybe some other base class that applet derived from. So what I'm saying is this. So object, so we probably have like object class, and let's say that the applet also derives from window class, and this is the applet class. And then you have our drawing demo 2. So can you guys see this? We have a very deep inheritance, starting from object class, then a window class, applet class over there, okay? And then finally, our drawing demo2 class. You guys following this so far? The point I'm trying to make is that just because we see on the screen that we extend from applet and that we can call getSize on the this operator does not mean that the getSize came from the applet base class. It might have been defined here instead. So in other words, you're not getting just the methods from the applet class. Rather, you get all the methods that, starting from the very top, the grandparent. Is that clear? My point here is that getSize does not necessarily belong to the applet class. Does that make sense? Okay, so here's what I'm saying. When you actually look in the Java docs, how does this affect you? When you look in the Java docs to look at, when you see this code, you might be tempted to think that, oh, the getSize must belong to the applet class. The getSize method must belong to the applet class. But then when you go to look at the Java docs, you find out that the applet class does not have the getSize method. And the reason is because that getSize method probably belongs to some other parent class that applet extends from. Okay, that's clear? Well, it's 10:40 now. I was hoping that I could finish the applet, but I didn't. But I want to wake you guys up and take a break, so take a 10-minute break. Wake up.
Before the break, Ajahn Siu would complain to me that students in the back, especially Hattori, didn't pay attention very well, so he kind of think that he will let me handle Hattori instead. Okay, so there's a change of plan in the after the break. Take a seat. Okay. So we'll change from the good-looking instructor to, well, just a common instructor. So please bear with me. All right. In the slides, you will see. Suppose that you have a slides, right? There are some, well, slides with some pictures of, well, silly-looking students and teachers drawing on a blackboard, right? Those set of slides were intended to teach you on what is called design patterns, right? And introduce you to a very cool design patterns that relate to interface. Unfortunately, we'll skip that, but we'll revisit those set of slides again next week, okay? But since we are running short in time, we would like to skip the thing and go straight back to how do we handle multi-threading programming. Basically, there are some things that will change your program forever, right? It's as big as that, okay? So we'll talk about thread. Before the break, we talk about applets. Think about applets as a class, all right? A class that we will make use of that class in order to create some program that runs in some special context, for example, on a web page. Okay? Let me emphasize again that in this class, develop software. When you develop software in this class, we will not think about doing anything on our own entirely anymore. We would like just to focus on tweak something from existing class and benefits from it, right? Create applications that take the class, override some methods, and obtain our desired behavior. Applet is a good example. Well, Ajahn Siu would say that nobody uses applets anymore, except for some very old web pages. I agree, okay? Our intention of including applets in the lecture, not because that we would like to just reuse the slides, but this is a very classic example. It is an easy class that you just take the class, override just one simple method, and you can obtain amazing results, right? So applets plays that part, okay? You stick with applets for a few weeks. before we move on to a full-blown application, right? That's upwards. Then here we'll talk about another class. It is a class that by itself complete already. It has properties, it has behaviors, right? But those properties and behaviors might not be the thing that we actually need in our end results, right? We'll learn these threads, make use of these threads, extend, create class by extend from threads, right? In order to achieve what is called multi-threaded program, right? Back to your Java class, you write a class with public static void main, right? And then you go to console or any kind of mechanisms to invoke that class. If the class has public static void main, that means Java knows the starting point of your program. And then it goes to that starting point, which is the public static void main, the instruction in that method, right? Then Java invoke things in sequence, from top to bottom. If it has control structure, it has decisions, it has loop, it follows the control structure, right? But in the end, that program that you write, it is called single-threaded. That means there is only single program flow. It executes things in sequence, right? But there are some other programs, other functionalities that we need something to happen in parallel. Two things to happen in parallel, or more than two things to happen in parallel, right? This kind of program is called multi-threaded program, right? Modern operating system, Windows, of course, you know that when you work on Windows, you can have multiple Windows running at the same time, right? Or even if you think about just single window, let's say a clock, right? Your Windows clock. As an ICE student, you're gonna need to realize that, well, the clock, it's ticking, it is ticking. Some processor needs to do some calculations in order to update the state of the time of that clock, right? Of course, that's one single program flow. But you can realize that in that program, you can, let's say, click the icon of the clock in Windows or on Mac, and then have the clock window pops up. The program flow underlying the logic of the clock is still working. But at the same time, there must be something that keeps monitoring the interaction of the user. That has to be another thread, right? So threads provides or enable this kind of thing, right? Or just in things that in a program that there needs to be some monitoring. Something is going on. Someone has to monitor some interaction. There must have to be more than one single control flow, right? In order to do that. And well, in modern processor, right? You have I bet that you have heard dual core processor, quad core processor, or 16-core processors, or even, I'm not sure whether, what's the maximum number that we have seen in the labs. There will probably be hundreds of cores of processor, right? A computer with more core or more processors, does that guarantee that that computer will execute the program faster than a computer that has less core or less processor? What do you think? So you go buy your laptop. One has just double core. Another one has quad core. Do you think it's better to go with quad core so you can play your World of Warcraft faster? I'm not sure which online games is in trend right now. I'm so out of date. Right? It does not necessarily mean that computer with multiple core can run faster. It depends on the program also. Right? If your program are so dumped that you run your program in single control flow, that means it can utilize only single processor. That means it doesn't matter how many cores do you have if the program runs in single control flow or single threads, right?
only one core will do the processor, will perform the processing. So nothing good comes out of that, right? So we will come back and looking at how to implement multi-threading programming in details after this. And luckily, Ajahn Silvabut is one of the experts in multi-threading programming, right? So hopefully your program will benefit from more cores in the computer, right? But anyway, we will go back and looking at how do we just basically create multi-threading programming by using a class called thread. First of all, I will tell you that basically today we will introduce at least 2 ways of achieving multi-threading programming, right? The first way is that Java has a class called thread. By itself, it is a complete class. You can create a thread by just instantiate that class. But like I said, we would like to override something. So common sense says that we just extend or inherit from that class thread. Just like your applet extend from java.applet.applet. Okay, that's the first one. And the second one is to do something different, which we will talk about. Okay, let's look at the first approach first. So, in this class, okay, let's go back to applet. You know that there is a functionality, there is a method, there is a behavior called public void paint. And you know that whenever the operating system or the browser needs to draw something in the region that the applet occupies, by default, since the framework says that, right, it will just call the method paint, right, in the class thread, right? Thread is something that will keep doing its own thing, but by its own thing, what does that mean? It does nothing much. We would like to override that thing that it will keep doing in its control flow, right? And the method to look at is the method called the method run, public void run, right? Suppose that we override the behavior of the threads by overriding the method run, right? In a program that we would like to make use of this thread, you just simply do these 2 lines, right? Let's analyze these 2 lines a bit. The first statement say thread T equal my thread. What does this line do? You do not have to know anything about thread more than this. You should be able to explain the operations that happen in this line. First, the program creates a variable called T. In Java, every variable must have type. What is the type of T? Thread. And equal new my thread. You're probably familiar with the keyword new already, right? It is a keyword that instantiate or create an object of a certain class. Which class it depends on your constructor after that, right? Suppose we have a class my thread. Oh, we learned in Java that we can only assign an object of a certain type to the variable with the same type. Are there anything wrong with this line? The variable T is of type thread, but the object that we create is of type what? My threads. How does this possible? If this possible, that means, well, somehow my threads must be a subclass of the class thread, right? Then we will override some behavior of the class my thread. Then we will make use of that. In order to make use of that, we just invoke a method called start from our object. And once we invoke the method called start, that means at that point in time, a new thread is born and then it executes its own thing in parallel with existing threads. Okay? Basically, what I mentioned before is that we provide the behavior, our behavior of our thread in the method run. But in this box, it shows on the slides that we invoke the method start. how does this relate? So again, it's already defined in the framework. The default behavior is that run actually contains the logic of what our thread's gonna do, but in order for other people or other program, other class to invoke this action, right? It is agreed that you do not invoke the run method automatically, directly. You invoke the method start. And behind the scenes, the framework will do something behind the scenes, and eventually the method run of your class will be performed, right? So, could you please? This is a very simple example of a thread, right? This is a class definition. The name of the class is infinite counter, right? Extends thread. So this infinite counter is a thread. Here, we define some attributes: delay, int, id, whatever. Okay. Then the next method, public infinite counter, and then some parameters. Do you still remember what does this call? This special method that has the same name as a class is a constructor, right? Normally in a constructor, it is a place where we would like to use to set some parameter, right? Which is the case which is in this case, all right? Then we have public void run. This public void run is from the last slide. It is where we put in the behavior of our own thread, right? Of course, we have some try catch. We will not worry about those details yet. But the thing is that we have an infinite loop here inside the run method. This infinite loop, what it does is that it just prints something by system out print line. It prints to the console. It prints some value out. This value involves the value of the variable I and id. Okay. Then after it prints this message out to the console, it increments the variable I by 1. Then it do this dot sleep delay. Okay. Of course, we haven't talked about the method sleep yet, but you can guess what should it do. Like the name suggests, this is a benefit of high-level language, right? The method name is meaningful, it means sleep, but who goes to sleep? Again, it's come back to the keyword this that Ajahn Sivu would point out from the last lecture. What is this? Is this instant this object? What is the type of the keyword this? Of the keyword this object? Thread. Right? Not thread, infinite counter, which is in turn, it is a thread because it extends from thread, right? So, same question as Ajahn Sivabut. Where does the method sleep come from? From out of nowhere, we just call the method sleep. We haven't defined the method sleep anywhere in our class definition. It must be defined somewhere up, which in this case is probably defined in the method thread. Right? But here, we just know that, all right, this method just makes this current program flow pause for a while, go to sleep for the number of milliseconds defined or assigned to the method, to the variable delay. This is all about thread, all right? But hey, wait. Here, I said before that I would like to create an infinite counter. We provide the class definition. But, we have public static void main in this definition also. Is this an error? Can we do that? Sure, right? Public static void main is just another method. It is just a method. But if we invoke these things from the console, this defines the starting point of the program. All right, so suppose we have this infinite counter, right? .java, and then we compile this thing, and then we run Java on this class. It can be executed because it has the method main, right? So, what are the operations of this program? Yeah, this line, right? Create a variable t1 of type thread. Then create an instance of which class? Infinite counter. And how do Java knows the details of this class? It's inside here because itself is the definition of this class also, right? So we do new infinite counter, and of course, we provide a constructor that takes ID and delay. So whatever it does, it just takes this, assigned to the attributes of the class, and then call t1.start. After we execute this line, all right, the flow, before we execute t1.start, there is one single program flow that is corresponding to method main, right? It is the one, that flow is the one responsible to creating this thread. It is the one responsible for start T1. And then once it starts T1, it will ignore T1 and keeps continuing executing the rest of the program, right? But in this case, the rest of the program, well, there is no rest of the program because this is the last statement. The program flow in the main method is there, but it will not quit the program yet because there is still this separate thread running, right? What does this t1.start do? So it's like one way the main method keeps executing. And once we execute t1.start, in parallel, we create another control flow. And this control flow will execute something, will perform something, but eventually it will call the method run of this object. The method run of this object runs, it goes into infinite loop, right? And then keep printing something out on screen. So from this code, what do you think you see when we execute this program from the console? What do you see? Well, you can guess from the name, right? It's just an infinite counter for something. It just prints out the value of variable I on screen, right? And then whatever ID that we assign here, print I on screen, update value I by 1, sleep for 1000 milliseconds, and then just keep doing this forever, all right? And too bad, after you run this, your programs will run forever. You're gonna need to hunt down java.exe or press some key to terminate the process, right? Could you please, do you have the code running?
Yeah, I have.
Right, let's just ignore about the real thing in this one. Let's just do multi-threading and run that. Okay, so the result is going to be something like this, but it's not very interesting because we just create one thread. Let's create more than one thread. Okay, please. So suppose with the same definition, we change the method main, right? And then here, instead of just the method main just creating one single program flow, we create two of them. Set each one of their IDs, and in terms of the amount of time it sleeps, right? So 1 second and 2 seconds. Okay. Another thing to notice here is that this is a style of programming in the case that, well, you would like to create a thread and you would like to just start the thread, and you don't have any desire to do anything more with that thing. So we do not need variables. So we can just do new infinite color, this one. This whole thing, this thing will be considered as an object of the class infinite color. And then we invoke the method start without wasting any variables, right? Chancery, could you please showing the program? Okay, this is a program that has a main method. The main method creates two threads. So at the end, at least it's going to have 3 threads running in parallel. The thread responsible for the main method. The threads created by T1 and T2. So this is the actual result. You see that there are two threads competing each other, right? It works in parallel. Okay, each has its own set of variable I, and it keeps increasing just its own variable I. Okay, since in this case we set the delay of T1 to 1000, while we set the delay of T2 to 2000, so we expect that the first thread will somehow produce the numbers that are twice as large. But let me mention to you that having multiple threads running at the same time, we can only estimate, or we can only roughly expect how often each thread will execute, right? The fact that we say thread 1 sleep for 1 second and thread 2 sleep for 2 seconds, it does not guarantee that at any point in time, it is not guaranteed that the number produced by one is just going to be twice bigger than the other one. It's not guaranteed. It's just roughly like that. We cannot control that in fine detail, right? This is the idea of thread. Okay, the goal here is that we would like to introduce you or basically challenge you in the homework to do some animation in an applet. So animations are just series of frames, right? Animations are just series of frames. And how do you perceive that it is a moving animation? Because the frames, each still frame, change from one frame to another fast enough for you to perceive as if the animation is moving, right? We would like to do that in an applet. Okay, let's think about this. Okay, let's say we will paint a ball, right? A football, okay, to be safe. All right, a football flying from left to right of an applet. Okay, let me ask you this first question. At this moment, can you draw a circle, just single circle, on a certain position of the graphics in the graphics object of the applet? Can you do that? How? You create an applet, right? You create a class extending applet. You override which method? The paint method, right? And how do you control that what is painted on screen is a circle? You call the method something, which I'll just Google and says draw circle Java, something like that, right? And probably the first choice that we obtain gonna be either one of the two, Stack Overflow or Java API, okay? Both works, okay? So, drawing the ball, you say that you call method draw string. Every time you call or you think about calling a method, you need to know which object or which class to call from. In this case, let's say I can tell you that the method to draw a circle, a big red nice circle is probably we do g.setColor to color.red, and then we do fill oval. Oval is more general than circle, right? And then we supply some parameters. What I would like to mention is that you need to know that you invoke this method from where? From the graphic object G there, right? In your program, you might have multiple objects of the class graphics, but this graphics G that is passed to the method paint, it is the only graphics that relates to what you see on screen, right? So you do G.draw fill oval and paint the circle. This method draw oval has an input that you can set the parameters. You can define the location and the size. Okay, you can draw a circle. Next, you would like to adapt this thing. You would like to create an animation inside these applets. Normally, what do you need to do with this applet? You know how to draw single frame on graphics. How do we create the animation to be appeared on the graphics object? Draw again, right? And who's gonna draw that? The program. There must be some subprogram or some program flow that keeps drawing, keeps activating, right, the method paint for us. Before that, the examples that Ajahn Silvabut showed, the method paints were actually activated many times. But the situations that activates those methods, it is because of Windows. For example, if Ajahn Silvabut minimize the thing or resize the window enclosing the applets, somehow the operating system knows that it needs to repaint the area. Underlyingly, it will automatically invoke the method paint, right? The concept of our animation is the same, but it is similar, but it is somewhat different in terms that we need to have something else that keeps forcing the applet to be repainted in the interval that we want. And in order to do that, threads is the thing that we look for, right? The problem is that, could you please go back to the slide? Okay, suppose we would like to have an applet that itself contains the detail of what to do when it acts as a thread. If we would like this to be performed in just a single class, we still have time left, right? If you would like this to be performed in just a single class, we need to decide that our class, would you like your class to extend from the applet class, or you like your class to extend from the thread, the thread class? You can only choose one because, hey, this is Java. It can only support single inheritance. Okay? Normally, if in this situation you would like to create an animation applet, you extend applets because there is some other approach in order to benefit from threads without actually creating a subclass of the class thread, right? So we will implement some interface instead. Okay, could you please? Okay, why don't we just skip to the code? Right. Let's say we would like to create a digital clock. Right? Well, let's keep this digital first. You, of course, you have seen that. You will do some fancy clock in your homework. So, this is a class called digital clock applet. All right? But this clock extends applet. Just look at the header at this first, right? It extends applet. Inside here, we will create some threads that perform the thing that you mentioned, keeps forcing the invocation of the paint method repeatedly, right? Okay, before this, we know that suppose we would like to have a thread that perform our own tasks. We will create a subclass of the class threads and then provide or override public void run. Okay, but in this class, we have that problem, right? There is one way. In order to do that, look at this line, right? Look at this line. You do not have to worry about anything else, just focus on this line first. It says new thread, this. And it assigns this object to this variable. This variable called main thread is of type thread, right? You know that this is to assign a new object of the class threads to this variable. Then, what we need to figure out is the meaning of this constructor, right? The meaning of this constructor. So, could you please go back a bit, on one slide? Another slide. Yeah. Okay. That is a constructor that can play significant role in this case. This constructor in the class thread has a header like this. It's a public thread and it takes these arguments. Okay, what does this mean by these arguments? What type of things it expects in this constructor to be passed along as its only input? What do it expect in here? An object, a class, a person, a car, an animal. What does it expect in the parentheses? Runnable. Okay. Make a noun out of runnable. Basically, in this case, it expects this variable target to be an object. Of which type? Yeah, you can say runnable type, right? But here, if I tell you that the name runnable is not a name of the name of a class, but instead runnable is a name of an interface, right? Given that right now you know that runnable is the name of an interface. Okay, can you tell me again about what to be expected for this object to be used as an input to this constructor? It can be any object that of type whose class implements the runnable interface. Okay, this is a bit confusing. I will repeat that again. What we expect target to be is an object. Okay, an object must have type. So this object belongs to some class. Any class will work. Any class, it could be an applet, it could be a rectangle or whatever that you define. But the requirement is that the class of this object must implement runnable. It can be student, it can be camera, it can be Ajahn Silverbut. Suppose you can create many instances of him, right? So, yeah, this is the meaning of this, right? So this interface runnable is very simple. Okay, let's recall. When we have an interface, all right, let's test this. Okay, let's test this. Could you please come up with a sentence of your own understandings to answer this question? What is a Java interface? Okay, your friends, so what is his name? Good. Okay, because I only see his back before. I can only saw his back, so he's good. Let's see whether his answer is also good. Okay, he says that a Java interface is a set of methods. Will you allow that to pass? Is it good enough? It's okay, but not good enough yet. Good answer, but incorrect. No, it's correct. It's correct, but not completely correct. It's correct in the sense that, okay, is this a set? You all learn discrete math. A set is a collection of objects where orders are irrelevant, right? So is this a set? But is it actually a set of methods? Is it actually a set of methods? Or if I have another answer to compete with him, if I just say that it is a set of method headers, it's not totally correct, but is it better? Can you see my point? Yeah. So when we talk about method, of course we go back to Java. When we define a method, we have a header, it is a promise, it is a declaration that anyone that would like to call this method must call it by this name, supply this kind of inputs, and expect it to return something. And also we have the body of the methods to provide what is called the implementation. Okay? When we declare interface, an interface is just a definition or a set that contains some numbers of method header, just the header, right? Without any implementation. Well, that will pass as a reasonable answer for what is a Java interface. Okay, I'm lost. Where should I go back to? Okay. Runnable interface is a set of a Java method header. When we talk about interface, we need to know how many methods are expected to be implemented if a class decides to implement the interface. For runnable, the number of methods that is expected is 1. Okay, it expects any class that implements the runnable interface to provide public void run. That's all. All right? And this constructor, what it does is just whenever you call thread t equal new thread and provide an object that belongs to a class that implements runnable. What it does is that it creates a thread object, right? The class of the object that is created is thread. But somehow, the definition of the run method of that object is switched. It's changed from the default behavior. Where does it take the method run from? If you need to guess. It just takes, when you call new, okay, could you please switch to the code, please? Oh, it's still running, and right now it's 1,000 already. Okay, this line. Main thread equal new thread this. What is this? An object that refers to this instance. And what is the class of this object? Digital clock applet. Does this qualify for that constructor that we talk about? Yes, right? Because in the header of digital clock applet, we promise that we implement runnable, right? The compiler, when it needs to compile this line, it checks whether digital clock applet implements runnable, right? And at the same time, it needs to verify that in the definition of this digital clock applet, that in its header promise that it implements runnable. It checks whether inside the definition that exists public void run, right? So this is the mechanisms that is very flexible in Java. It means that you can put in any type of object, right? As long as the class of that object implements runnable. But with this constructor, it takes the logic of the run methods to this object. Okay, that means when you activate the method start of this object, a separate program flow is created in parallel with the main one, right? And eventually it will invoke the run method. But the logic of the run method, it takes from the definition of this class, which is here. All right? So that's the idea of the second approach, that we create a thread object. The first one is that we just simply create a class that extends threads, and then we override public void run, right? The second one, in the situation when we would like to create a new class, but we already extend that class from something else. That's a choice, right? You can make your class implement runnable and provide a method run. And whoever would like to create a thread that benefits from your run method, it can just use that constructor, threads, and then the object of your class. Okay. So let's go into the detail of this digital clock applet, right? Ajahn Sawut, could you please run the applet first? Okay, this is a silly program compared to what you're going to implement in your homework, all right? So this is an applet that shows the current time, which it tells me that we have, well, almost 20 minutes left in this class, right? Or do we have one hour and 20 minutes? Do we usually stop at 1 o'clock in the afternoon? Right? No objection. Okay, good. All right.
Right now we are all.
Okay. All right, but anyway, I will keep going anyway. All right. Okay. Before I continue, do you have any questions about threads? Feel free to ask Ajahn Silverbut. Anything? Okay. Or do you have any question about anything? Feel free to ask Ajahn Silverbut. Okay. So before, I would like you to just know that there is a class called Threads, and Threads can provide the functionalities for us to create a separate program flow. We can create many threads runs at the same time, right? And in order to create threads, there are probably two ways at least. Create a class that extends from threads, or create a class that implements runnable. And then we use a constructor of the thread that takes that class, right? So this is an applet. Let us together think about what needs to be done in order to achieve these results, right? First of all, we talk about animation. We say that the fact that we see the time keeps ticking is that the applet paints itself with the current time. But there must be somebody that keeps telling the applets that you need to repaint yourself, right? So at least we know that in order to draw this time on screen, we need to at least override which method? Paint, public void paint, right? When we talk about method, let's just keep the full header. Public is fine, it could be private or anything, but void paint, all right? Void paint. What would you like to do in the paint? What would you like to do in the paint? Somehow okay, what is the method that eventually you will call in order to put some text into the graphic subject? Drawstring, right? Drawstring takes a string, but you would like that string to reflect the current time. What does that mean? That means that you need to do something. You need to obtain the time, right? You need to obtain the time. How do you obtain the time? Google. Get current time Java, enter. You run into, well, answers. But too bad, I'll try that. We run into many possible answers, right? Let us present you a simple answer. We can use a method called, a class called calendar. Let's look at this code. The paint method will, whenever the paint method is invoked, it will do this. Dimension D equal this get size. Of course, if you are not familiar with dimension, you're going to need to go to JavaDoc and consult the documents. All right. Then calendar C equal calendar get instance. We create a variable C of type calendar and assign C with some instance. Calendar.get instance. Calendar is a method, the class name. Get instance is a method. So, is this method static or non-static? Oh, static, right? It is the behavior of the class. We do not to create an instance in order to invoke a method, right? So this method will just get an object. It creates an object of the calendar type with itself, with the information of the current time, right? Then int h equals c dot get calendar, calendar out of days, things like that. So if you consult the JavaDoc of calendar class, you run into the method get hour, get minutes, get seconds. But at the same time, if you look at the JavaDoc, it will say deprecated. Deprecated means it will not be continued in Java anymore in later version. So if you go into JavaDoc and you seems to like some method, but it says deprecated, right? Do not use it. Find alternatives. Okay. So the method that in the future, I'm not sure about Java 7. Okay. Do you have any info? Well, but at least this method stays for a while, right? Method get anything. But if you look at the header or the documents of this get method, it takes an int. Each int will corresponding to each field, hour of day, minutes, seconds. But of course, we will not know that integer anyway, right? But anyway, those integers are defined already inside the calendar class itself. So inside the calendar class, it has a field, a constant field called hour of day, constant field called minutes, constant field called seconds. Those fields, its value is not the real hour of day, minute, or second, but it is just an integer that represents the field. And we use that integer with get. So that's why we do c.get and calendar hour of day. It will retrieve the hour, the digits of corresponding to the hour of that calendar. And we store that in h. Same thing goes for m and s. All right. When we set color, we draw fill rect to draw the background. We draw string. Okay, look at this logic. H divided by 10 plus h modulo 10. What do we do here? Why can't I just say h? What is the meaning of this expression? H is an hour of day. Why do I take that hour of day and divide it by 10 and then plus h modulo by 10? Anybody can see my... Yeah, so h, normally it runs from 0 to 23. I'm not sure whether it runs from 1 to 24 or 0, I think 0 from 23. Suppose I would like my clock, digital clock, to be very fancy. That means it's always show 2 digits for the hour, right? So, is this necessary? This blank string here? Yes, it is, right? Because if we don't have this, h is an int, divided by an int is going to be an int. If we don't have this, h mod 10 is an int, so it's the summation of int. So I put this here in order to force the second plus sign or the rest of the plus sign to be concatenation of string, right? So this is just a simple trick to obtain 2 digits, right? And same things go here, 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 and whatever. right? Well, I will not talk about this. If you are interested, if you think your applets will be more fancy, if you can set the font to be shown on the applets, feel free to consult JavaDoc. All right, that's pretty much it. Let's adapt this code a bit. Let's say this is a clock that is very lazy. That means all it does is just show time. What kind of clock? What kind of clock that is this lazy? Only show times. A clock should walk, right? Let's say we would like an applet that the time, it keeps showing the current time, but instead of just saying still, showing its laziness, right? We would like to see this clock drift on screen horizontally from the left to the right. And well, basically if we run long enough, it goes away. Which method do we need to tweak? Drawstring, of course, right? Drawstring is the method that we draw something on screen. And how do we change it? The position. And which position do we use? Okay, we are not done yet. I'm sorry, I forgot. What we just talked about is how do we paint a single frame, right? So let's go back and see the method public void start. Okay, let me point out to you that this method starts is the method that this method overrides the method start in the class applet. It is different from that start, main thread.start. That start is the start method defined in thread. Okay, there are two different starts here. Right. So public void start is another method in the class applets that it is worth looking at. The method paint in the class applets, it will be invoked whenever that area on screen needs to be repainted. The method start will be invoked anytime that the applet starts. For example, suppose you embedded these applets in a web browser. If you go away from this page and the applet, if in that case the applet is still in the memory, Java will invoke the method called stop. Then if you revisit, basically hit back to this page again, it will re-invoke the applet by calling the method start. It is true in the first time that we run the applets also, right? So the method start, we can think about this in this case as whenever we are going about to, well, right after we launch the applets, method start gets invoked. Okay, start of the applet, not start of the thread, right? And we check main thread equal null or not. Well, let's just ignore this condition first. Let's look at the logic inside the decision. It says main thread equal new thread, this main thread dot start. We should be very, very familiar with these two lines already, right? Create a thread whose run method comes from the definition in this class. Then main thread.start invoke, make the thread start running. Okay. The reason why we have to check if main thread equal null is that if somehow at some circumstance, which I don't know, but Ajahn Sivut can answer, I trust that. Right. So if you have questions, ask Ajahn Sivut. Right. At some moment, there might be a situation when the method start is invoked, but this variable main thread is not actually null. It is actually points to the actual current thread that is valid already. We will not re-instantiate it. But if it is the first time, right, main thread will be null by default. It is the first time, just create a thread and then start it. If the thread is there already, do not start it. Right? So it is the meaning of this method. In the run method, the logic of a thread is that it is just I'm not sure whether the terminology in the gaming world is that mechanical Turk or something like that, right? So just, well, doing something repeatedly. What it does is that, well, ignore the while loop first. What it does is that it's called the method repaint. Oh, again, repaint. We do not see any repaint inside here. Okay, let me tell you that repaint is a method of the applet class. We always call the method repaint when we would like to forcefully invoke the method paint. Can you see what I mean? It means that the logic of how you paint your applet belongs inside the method paint, but when you would like to activate the method paint, do not call the method paint directly. The framework says call the method repaint. It will do something necessary behind the scene, and eventually the method paint will be reached. Do not worry, right? So we just now take that. Whenever we would like to force our applet to be repainted, or whenever we would like to force the paint method to be invoked, we call the method repaint. Then this one just makes the threads sleep for some time, and then when it wakes up, it will repaint again. Okay. How does the time get updated? Where does the actual time get updated? It's inside the paint method itself, right? Because inside the paint method, we get a new calendar with the current moment, right? So at each time the paint method is invoked, the program will fetch the current time, right? So it's like we have a thread, we start a thread, this thread, paint, sleep, paint, sleep, paint, sleep, paint, sleep, paint, sleep forever, right? But the logic of the paint method actually changes states or change the parameters of what to be painted on screen, right? So let's come back to, well, making the time flying from left to right. Which method do we have to worry about? Oh, okay, your friends already mentioned we need to fix something in the parameters of drawstring. We need to fix the position, which is somewhere here, right? And right now it's here. 5 is the top left position, top left corner of the string. If we draw a rectangle over the string, we fix it at 5, and d dot height, d we get from the dimension of the current window, divided by 2 is around half of that, right? So which do we need to change in order to make the time fly from left to right? 5. Change to what? 10? How about 15? How about 100? It needs to be some variable, right? So our applet should have another extra variable to store the value of this position x. And then that value needs to get updated accordingly. All right. So we introduce, well, magic. I just think about that and it appeared. Okay, current x and step, right? Step means when the thread wakes up, how many pixels would we like to update current x? Okay, this is another method init. Again, I'm too lazy to talk about this. So look up init and start by yourself, right? But it sets some variables. So we change this value to current x. Is that all we do? We need to update, right? In order to make animation, repaint, sleep, update, repaint, sleep, update, repaint, sleep, update. Okay. Great. Okay, that's it. Do you believe that this worked?
Yes. No.
Okay, it's moving, right? We still have the whole hour left. What should we do? All right. Okay, I'm kidding. So let's just let Ajahn Silvabut. Do you have the homework to applets? Okay. Just give microphone to Ajahn Silvabut because I know that you are bored with my face already. You would like to listen to the good-looking instructor. So here you come.
Do you want to show the actual application, the homework too? Okay.
So just spend some time to brief you on the homework and give some idea verbally. Well, Ajahn Silvabut is going to give you all solutions to the homework too. But everything will be given in the air verbally. Okay?
So, have you guys looked at the homework too?
Yeah.
The uploaded homework too? Let me first briefly describe the the two parts that you are responsible for. Okay, in a nutshell, there are two parts to your homework too. There's the My Avatar part. You're responsible for trying your best to draw your face so that it hopefully at least resembles your face a little bit. And the second part is to actually put a clock or a My Avatar clock using that face that you just created. Put it in another applet. Okay, in other words, reuse it. Ja, I mean not ja, Nai. I think that you guys can, since we are short on time, you guys can review the specification yourself for the first part. As for the second part, again, we want you to utilize applet and threads to repaint the applet such that it creates an animation. And as I have shown you prior to this, your homework should look something similar to this, right? It should be animated, yeah? And just to convince you that this is all possible, we're going to run the code that Ajahn Atiwong has already developed, just to show you.
The rumor that it's last 1,000 lines are wrong, right? It just takes like a little bit less than 100. Just that. Just that short.
Okay, so this is not the homework, but I just want to demonstrate. Okay, this is
the first part.
Right, the first part, right? The first part is you're supposed to draw your face, okay? And you can achieve this by simply just calling the right methods, right? Like draw oval, you can see circle, lines, figure out how to call the method to draw lines, right? Or fill color, right? Blue. So I think the first part, as long as you figure out the right methods to call from Java docs on the graphics object, you should be able to complete the first one without any problems. I think the challenge will be, Vicky, I think the challenge will be how do you draw it such that it looks sort of like your face. Yeah. Okay, so that's the first part. Oh.
that's the code on the right, if you can catch it.
That's why I quickly closed it. So this is not a YouTube video, as I was showing you. This is actually a running applet, okay? And you can see that it's doing animation, right? If you actually read the homework specification in the second part, you'll see that we mentioned the term double buffering. And in computer graphics, double buffering refers to optimization to reduce the flicker that you will occasionally see. If you look at the screen long enough, sometimes you'll see it flickers. Last night when I was running it, it actually flickered a lot. Did you see it just flickered now? So what we're showing you here is the completed applet for the second part, but without double buffering. Okay, in the homework, I think Ajahn Atiwong was nice enough to create a link to the double buffering so that you can read more on it. So certainly you can turn it in like this without double buffering, right? But if you are capable enough, we hope that you can submit it, turn it in with double buffering. In this applet, it doesn't matter how long you run it for, it will not flicker, because in this applet, Ajahn Atiwong implemented the double buffering technique. Okay, so how do you do this? What part of the applet is being animated? Can you guys tell me? How many parts? Two. What are the two? The eyeball and then the time, right? So what do you think is the concept that we learned today that you'll be using to implement the animation? What's the keyword? Thread. You have to use multi-threading to animate this, right? So you'll have to figure out when you probably also want to keep some sort of state, maybe? Do you think that you need some sort of state to solve? No, not state. So if I were to solve this problem, perhaps what information do you need to be able to draw the right time? The current second, right? I mean the current time. So you probably want to find out the API to get the current second at this minute, at this very second. And then what are we drawing this animation, the time? What are we drawing? Like, you probably want to figure out the angle, right? Based on, like right now, if the time is 5 seconds, you have to figure out what angle that is so that you can figure out on your line of circle the location where you should draw. So do you think this is something doable within, how long do they have for this assignment?
Well, a couple hundred hours. Okay. Well, it is due again on Thursday.
Mm-hmm.
On Thursday. No? That is yesterday. Oh, wait. Okay, Ajahn Siwoo, could you please show how long the code is in the last one, the double buffering? You see that it's very, very short, no more than 20 lines. That's the one for